In this lesson, we are going to talk about solving systems of linear equations. All right, the first thing that we want to do is we want to just try to graph these inequalities, try to recall what we've done in the previous chapters. Graph these just like you would any other line. The y-intercept, 1. Slope is 2, up 2 over 1, 2 over 1. And then don't forget, we've got those lines, and we need to decide, do we need to draw a solid line or a dotted line? This says that y is greater than this. It doesn't say that it can be equal to. So we want to make a dotted line through these points. Okay, just like that. The next part says that y is greater than that. Okay, so you look on the y-axis. Y is bigger than this line. So if this is the line and y is bigger, you shade above. And that's it. Okay? Go to the next one. Y-intercept, -5. Slope is 1/2, which means up 1 over 2. 1 over 2. This 2 will have a dotted line because it's not equal to it. All right, so go ahead and put that on there. Make your dashed line. And then decide, do I want to shade above or below? Well, in this case, it says that y is less than the line. Here's the line, here's the y-axis. Y is less than it. So it is shaded below, like that. Okay? All right, here are my notes. The solution to a system of linear equalities is an ordered pair that is a solution of each inequality in the system. The graph of a system of linear equalities is the graph of many solutions of the system. Okay, there's more than one. There's more than one answer there. When you graph a system of linear inequalities, the first step is that you want to graph each inequality, including shading all possible solutions. Okay? So, what we want to do, and don't forget, remember that dotted or solid line, one of the two. Find the intersection of the half planes, the shaded areas, and graph this system of intersections. Okay? All right, here's our first example. Y is greater than -x minus 2. Y is less than or equal to 3x plus 6. All right, they thankfully retyped them both right here for us. All right, find the intersection of the shadings. This is the solution of the system of inequalities. Start with this one. -2, slope of -1, which means down 1 over 1. Over 1. Please don't forget, if you're ever confused, remember that anything with a negative slope leans like this. I'd be walking downhill. Positive slope is like this because you're walking uphill and the function's increasing. This function is decreasing, which means it has negative slopes. Okay, so I've got this right here. Ask yourself, dotted or solid? Cannot be equal to it, can only be greater than, so it is dotted. Okay? And y is greater than this line, so it is shaded above. All right. The next one, y is less than or equal to 3x plus 6. I go to 6, make a dot, my slope is 3. Up 3, 3 over 1. It's pretty steep, and I go down 3, back 1. All right, in this case, because it can equal the line, then we will create a solid line, straight through. Ask yourself, do I shade above or below the line? This says that y is less than or equal to the line, so I shade below the line, causing this overlapping part, and this is my solution. Okay? All right, let's do another one here. Example 2. Now, I've got y is greater than or equal to negative 1. All right? Before we do step 1, let's just make sure that we remember this is a solid line, and this is also going to be a solid line, because both of them can equal it. All right, step 1, rewrite the second inequality. Now, why do you think I need to rewrite this? Yep, that's right, because I need to get y by itself. The first step in getting y by itself is to get rid of the x. I will just subtract the x over to the other side. Okay? Now, I don't want the 2 there. The 2 is being multiplied by y, so we are going to divide everything, we need to be fair, by 2. And I end up with y less than or equal to negative x over 2 plus 2. Now, this whole negative x over 2, that's a little awkward to try to graph because it's not evident immediately what the slope is. The slope is actually negative 1/2 x. This and this mean the very same thing. But when it's rewritten like this, you can now see what the slope is. There is an imaginary 1 right next to the x, causing this to be a negative 1 over 2 right there. And then you can put the x off to the side. All right, now let's graph them. Let's start with this one because we just have this right here. Y-intercept of 2, slope of negative 1/2, down 1, right 2. Okay, solid line because it can equal it. Y is less than this line, so we will shade below the line. The next one, y is greater than or equal to negative 1. I go to y where y is negative 1. This is a horizontal line. It's a solid line right here at negative 1, and y is greater than this line, so I shade above. The overlapping part in this case is this little sliver of a piece right in there. That is my solution. Okay? All right, the next one. Oh, once again, I need to get y by itself. First, all of these are even numbers, which means I can divide everything by 2 to begin with. X plus 3y less than 3. Subtract the x. (3y) less than negative x plus 3. Divide by 3. Y less than, remember up above where I had negative x over 2? Same situation, this time I have negative x over 3, which means I have a slope of negative 1/3 x plus 3 divided by 3 is 1. Now let's graph this one. Y-intercept is 1. Slope is negative 1/3. Down 1, right 3. Down 1, right 3. It is a dashed line or a dotted line because it cannot equal it. Whoops, I didn't go over enough. There we go. So connect our dots. Dashed line. Y is less than that. The next one, let's graph this one up here. Y is greater than 1/2 x minus 4. Minus 4 is my y-intercept. Slope is 1/2. Up 1 over 2. 1 over 2. Once again, it is a dotted line because it cannot be equal to it. There we go. Now, on this one, y is greater than that. So we shade above. And we get this part right here is my overlapping area, my solution. Okay, Doing good. All right, sometimes they actually give you a graph, and they would like you to write the system of inequalities for this graph. Let's begin with this solid one. The y-intercept on this solid line, we're going to do y, shaded below, so that means y is less than. It's a solid line, so it's equal to. It's going to be something plus 1, because that's my y-intercept. And what's the slope? Slope is up 1 over 1. The slope is 1, so it's just x. This equation is a horizontal line. It's a flat line, which means it's a y equals line. And it passes through 1, 2, 3. It's shaded below, which means it's less than, and it's dotted, so I don't put the line underneath for it to be equal. So there I am. All right, now, I want you to pause this video for right now, and I want you to practice 1, 2, 3, and 4 for me. All right, go ahead and pause it, and then we'll come back in a second and see how you did. All right, how'd we do? Here are the answers, and so you can check to see if you did them correctly. Here is the first one, number 1. Shade above, shade below. One of them is solid. Let's see. This one actually should be solid, and I have it dotted, so let's change that real quick. There we go. And we shade, this is the part. Over here, I've got solid. Now this one right here, x is less than 3, that's a vertical line. X is less than 3, which means you go to the left. There's my overlapping part. On this one should be shaded like such. Shade above, below, there's my key part. My last one right here, my two equations would be y is less than 2x, dotted, and y is greater than negative x plus 3. Both dotted, so there's no equal to. Your homework is section 3.3 in the book, page 136, these problems. Next class is Tuesday.